So today we're going to talk about function composition and inverses. So basically the idea is we're going to put two functions together and we're going to use that to prove inverses at the end. So this is kind of a lot of things to learn about today, but all, in my opinion, not too difficult. So we have f of x is an equation, g of x is an equation, and h of x is an equation. And we want to do g plus h. Now remember, these are just names. So what I'm going to do here, just highlight some things. So notice that g of x is that, and then h of x is this, okay? So what I'm going to do is I'm going to write that out. So I'm going to put in parentheses negative x to the 1/2 plus 4 plus negative 4x to the 1/2 plus 1. And now that I've substituted them, I just do like terms. So these are like terms, that is because we are adding. So we have 2x to the 1/2, so we have 5 of them. Or sorry, there's two like terms, negative 1 and negative 4, which make negative 5. And then we have these numbers, so 4 and 1 make 5. Same thing here when we subtract. I have another one here. Oh, we already did g of x, that's in yellow. But we have one in purple here now, which is right there. And then we still have the same g of x in yellow. So I'm going to put them the same way. Again, I'm going to put them in parentheses, like so. Now, again, if you remember this back a while back ago, when we are subtracting, it's a little confusing because we have that minus sign we have to distribute. Once we distribute the minus sign, then we can do some like terms to get the answers we're looking for. Okay? And that's called function composition. We're adding them or subtracting them. That also means we can multiply and divide. So this is the same thing. We're just redefining these. So g of x, again, is right there. H of x is right there. And they're multiplying. So we have g of x and then h of x. So negative 3 is going to come down. We multiply these x's together, so we're going to add the exponents. So we're going to have to find a common denominator. So we're going to have to get 6 here. So that's 8 over 6 plus 3 over 6. So it'll be 11 over 6. And we're done. So that's actually a review from what we did last class. Same here with g of x. Here g of x is yellow. H of x is green. Looks like we forgot to use f on this one, but that's okay. You'll get it on your worksheet. So g of x over h of x. Okay. Now there is a 1 here, so when we divide the numbers, we're going to get negative 3. We'll still have an x, but we have 4/3 minus 1/2. Again, we have to make common denominators, so we get not 12. 8 over 6 minus 3 over 6. So we're left with 5 over 6. That makes sense, hopefully. Makes sense to me. Alright, so we're just combining functions. So rather than writing out the equation every time, we can write out the names and it's a little quicker. Function composition is a little interesting, okay? So I'm going to start with g. So you always start with the outside one. So I'm going to write a little step here. So step 1, start with outside function. That's what it's called, not an equation, it's a function. So we have 3, I'm going to write the x real big, plus 2. Then step 2, we're going to change x into a whole equation. Okay? So this is g of x, f of x. F of x is right there, and we're going to change this x. So I'm going to have 3 f of x, and then bring down the plus 2. So notice how that worked, okay? So f of x right here is going to go in for the x of g. So this is g of x. I'm going to erase this, and I'm going to put in f. So it's weird. We're putting one whole equation into another equation. It's kind of goofy. Okay, and then we're going to distribute. So we get 6x plus 6 plus 2, and that's going to give me 6x plus 8. And so if this was like a multiple choice question, they would write this. This is how they would write the answer. Okay, or they would just write 6x plus 8, depending on how it was written. And that's called, this is all function composition that we're learning. Now we're going to talk about inverses real quick, and then we're going to come back to function composition, because function composition is another way to prove inverses. So an inverse function, so if you have plus 2, the inverse is minus 2. If you have a times 2, the inverse is divide 2. If you have 2 comma 6 as a point, the inverse is 6 comma 2. Okay? Those are inverses. They're working backwards from each other. And so to find the inverse of an equation, the step 1 is to switch x and y. Okay? So when I switch these, I'm going to get x is equal to 3, y minus 6. So this is the original, and then we're going to find its inverse. Just like plus 2 cancels with minus 2, this equation is going to cancel with another equation. So then step 2, we're going to solve for y again. So we need to get y by itself. So here's y. Okay, and we have a power and a minus 6 to get rid of. So to get rid of, well, it's a root. So the opposite of a root is a power. I apologize. So we're going to do a power to both sides. I'm going to do that in red. Okay, or green. I'll do it in green so it matches the green that I'm doing there. So the green I added, so that x to the third is going to come down. Those are going to cancel. So we'll have to y minus 6. And then again, we got to get rid of that 6 that I highlighted in green. So we're going to add 6 over. And that is the inverse. So the reason why these are inverses is they're completely backwards from each other. Instead of a root 3, we have a power 3. Instead of a minus 6, we have a plus 6. And so they are completely backwards from each other, and that's why they're inverses. What that means is if I put them together using function composition, they're going to cancel each other out. Okay? And that's our goal today. Now this first thing I forgot to mention is it says state the domain and range. Okay? So we're going to talk about that. Is there any numbers that I can't put into here or here? Well, no. Is there any numbers can I not get out? Well, no. So domain and range are going to be all real numbers, meaning that you can use any number. Now, I'm going to talk about this more in a minute. All real numbers. Or another way to write it, how they write it mathematically, is a little r like that with 2 bars. So 2 bars are, that means all real numbers. It means can you get any number in or out. Okay? Let me just show you an example of a domain that doesn't work. Okay? This is a fraction. I can't have zeros. Okay, we can't have a 0 there. So the domain here is everything but 0. I can pick 1, I can pick 2, I can pick -2, it'll be a -half, right? But I can't pick 0. If I pick 0 here, I get a 0 in the denominator. It breaks a rule that we know of. So the domain for something like this would be everything but 0. Okay, we could talk more about how to write it. Same with the range. We can't get 0 for the range. So if you're given something that you're like, I think I could use every number in this problem, then you have all real numbers. Another example is square roots. Like if I have the square root of x, I can't have negatives. Okay, because they can't put a negative in a square root. This is an imaginary number. This doesn't work. We're talking about real numbers right now. So the domain here would be all positive numbers or no negatives, which means the range would be the same. It would have to be all positive numbers or no negatives. Okay. So that's the synopsis of inverses, and you're going to get a lot of these in math. So hopefully you understand that. So now we need to verify inverses. Now remember, inverses, they cause everything to cancel. So in order to do this, we're going to step 1 is you need to do f of g of x. Okay? So we're going to do f of g of x. So if you remember what we did before is I highlighted f. Okay, we highlighted that, and I said, okay, let's write f out. So it's x squared minus 1. and then we have g of x inside. So I'm going to take this x and write g of x. Okay, so notice that the greens are all the same. So here's x squared. It's going to change to the green, but notice the squared and the minus 1 still come down. Okay? Now what does a square root and a square do? They cancel. So I'm left with x plus 1 minus 1. Those cancel, so I'm left with x. This means they are inverses. Whenever all the number cancels, it means that they're inverses. That's the point of inverses, is everything cancels out, right? I mean, a plus 2 cancels with a minus 2, a root cancels with a square, or a plus 1 and a minus 1 in this case. So we know things are inverses when everything, all the numbers cancel out, and we're left with just x. The other part is, step 2, is we have to do it backwards. We have to do f of x, or g of f of x. So we have to do it backwards. So that means we're going to do the green part first, and then the purple part. So the green part is the square root of x plus 1. Then this guy here is going to become the purple part. Okay, so we have the square root. The purple is x squared minus 1 plus 1. Well, what happens to these? They cancel. So we're left with the square root of x squared. What happens there? They cancel. So I'm left with x. Again, it is an inverse. So remember, inverses that we're normally used to are like plus 2 and minus 2, plus 5, minus 5, where we can have inverse equations, where when we put one equation with the other equation through function composition, everything cancels. So we can have multiple inverse numbers happening at the same time to cancel out each other's functions. Okay? And the reason why this is important is this is the standard. Okay? This is what I'm grading you on. I'm technically not grading you on domain and range. All right? So you can kind of see where the A is, right? Because domain range is above and beyond what I'm grading you on when it comes to this, right? So that being said, make sure you understand that this right here, what I did first, is kind of the A-level question, being able to find an inverse of anything. Give you something, find an inverse. The B comes from doing function composition. So if you can't do function composition to prove inverses, then we're going to have some trouble. Okay, so make sure you understand how to do this last part. That's the important part. This is the standard for this section, but in order to do all this, we had to know what inverses were, right? In order to do inverses and function composition, we had to know what function composition was. So you can see why I had to start up here, which would probably be a C or D grade, if you can just do those, and work our way down to our B grade down here, and then provide an A opportunity using domain and range. Okay? If you have any questions, let me know. I'd love to help you. Have a great day. Bye.